Hello, and welcome to Turning to the Right, an ongoing video series where we will discuss all things energy with a focus on oil and gas. Today we're going to be taking a closer look at a topic that is often discussed, but not frequently analyzed. ARP's hyperbolic equation and terminal declines as they relate to differences in reserves and present value. Specifically, we'll look at how gas production is distributed over a 50-year well life using reasonable decline curve inputs, and the effect a change in terminal decline has on reserves and present value. So let's take a look at our example well. So for the exercise we're going to do, we've set up two scenarios, and the only difference between these two will be the gas production curves. So we have assumed a 50-year well life, and our two production curves both have initial production rates of 10,000 MCF a day, initial decline of 60%, B factor of 1.2, and our first production curve has a terminal decline of 5%. Our second production curve has a terminal decline of 8%. We have one water curve that we'll use for both scenarios 1 and 2. IP will be 800 barrels per day, 85% initial decline, B factor of 1, and a terminal decline of 7. And that water forecast will be used just for the expenses. Our gas price, we're assuming a $4 flat gas price, fixed operating cost of $1,700 per month, variable gas op cost of 3 cents an MCF, variable water disposal cost of $2 a barrel. The interest used were 100% working interest and 85% net revenue interest. So let's take a look at our production, and we're going to start out by looking at only our 5% scenario just to get a feel for how those volumes are distributed throughout the life of a well. So I'm going to go ahead and maximize our sort of volume versus time graph here, and what we're seeing is the production year on the x-axis here, and currently I have in yellow the annual volume produced. So let's just look at that real quick. That's what these numbers represent. So we're looking at about 2.2 BCF in the first year, 1.1 in the second year, 0.8 in the third year, etc. And as you can see, those trail off in the last 20 to 30 years and are significantly smaller. If we go ahead and remove that volume, what we're left with are these other bars, and these bars represent the percent of the EUR that is produced in any given year. So looking at our first year here, 18.6% of the gas is produced in the first year. The next year we're about at half of that at about 9.9. Third year 6.6%, 5%, etc. And the big thing to notice here is as we get out into this looks like about year 27 and beyond, all those years are less than 1% of gas produced, with that last 10 years being really less than 0.5%. So we're talking about very small volumes being produced out there. Okay, so if we look at that on a cumulative basis here, we see sort of the same thing, that around 20%, 18.6% in the first year. Looks like we get to 50% in years 5 through 6, and we're at 75% somewhere around years 16 through 17. So the majority of our gas, it looks like, is produced pretty early on in the well life. But how is the cash flow, discounted cash flow, distributed? So what we're asking there is, how do we really value those reserves? So let's go over to this page that shows cash flows and take a look at that. So based on those input parameters that we discussed previously, you can see here we have the discounted cash flow at 10% for each year. So obviously as we go out further in time, that discounting is going to have a larger effect. So you can see that cash flow is skewed even more to early life than the gas production. So here in the first year we're making about 7 million, and then again you can see that is actually less than half in the second year, and then by the time we get to year 10, we're down to only $395,000 in discounted value. Okay, so then if we go over to a cumulative percentage plot, so we'll skip the percentage plot, you can see that 33%, so a third of the value is actually produced in that first year. By the end of the second year, you've produced 50% of your value, and you're at 90% plus of value in the first 11 years. So that ties to things that we've seen some operators doing, which is as their production base gets older and they're continuing to develop their acreage positions, they're actually selling their old PDP wellbores because they're of de minimis value in comparison to those new wells they're bringing online. And this would especially be true with the increases in oil and gas prices that we've seen recently at the time that this video is recorded. Okay, so all of this again is looking at our input parameters with that 5% terminal decline. So the other question we want to answer, now that we've kind of seen that distribution of production and cash flow throughout the well life, is how much difference would it make here for either if we were to change our decline to 8%, or terminal decline, that is. So instead of trying to look at that on a graph, because the differences aren't very large, let's just take a look at a summary here. So first let's look at gross gas. So our 5% case, which is our base case on top here, we're at 11.8 BCF. If we change our terminal decline to 8%, we go to 10.5. So looking at that as an increase of 10.5 to 11.8, that's a 12% increase. So that's actually a significant increase over an 8% terminal decline if we move to a 5. However, if we look at the difference in cash flow, discounted cash flow that is, we'll see that the power of that discounting come into play. So here at the 8% terminal decline, we're at 20.07 million, and going to the 5%, we only go to 20.4 million. So that's only an increase of 1.6%. So a question we commonly get is, what terminal declines do we use for oil and gas? And that will depend on the type of well and reservoir we're looking at. So when we're looking at newer horizontal wells that have been drilled in unconventional formations, and in a lot of those where none of the wells have actually reached a terminal decline rate yet, we'll use 5 to 6% for gas and 6 to 8% for oil. But when we're looking at older wells, where some of those wells are actually, the older vertical wells where some are actually in the exponential decline phase of their producing life, or where there are offset wells that are in that exponential decline phase, and we have data to verify a lesser terminal decline, we might use as low as 3 to 4% for oil and gas. So hopefully this has been insightful and just provided a little more information on the considerations we need to make when evaluating oil and gas reserves and value.